Solving inequalities. Well, how do I solve inequalities? Well, you'll find it's very similar to solving equations. There are a couple of differences. So let's just take a look at our notes here. Here we have a two-step inequality, and you would solve it exactly how you would solve an equation. You have to be careful, though. There are certain instances where the symbol will change direction. And let's talk about that. Now, if you look in this box, if you do these things, you're fine. The symbol will remain the same. You can add and subtract numbers from both sides of the inequality. You can multiply or divide both sides by a positive number. That's fine. It won't cause the inequality to change direction. You can even simplify items on one side of the inequality, and that's fine. However, if you do multiply or divide by a negative number, then that will cause the inequality, the symbol, to change direction. We won't do a lot of that in 6th grade. You'll do that next year. However, there is one instance this year where you will have to change the direction of the symbol, and that's in this example here. We really want to, even though when you solve this, this is a one-step inequality, and this would be a perfectly acceptable solution. 7 is less than x. But you really want to have the x on the left side of the inequality. And so if you got this as a solution, you could rewrite it. But when you rewrite it and you switch sides, when you have the x go on the left-hand side of the inequality, you need to reverse the symbol. And we'll take a look at that in a couple of examples in this video. So let's solve some of these inequalities. First, we'd get rid of the constant. And now we're left with a one-step inequality, and we're going to multiply by 2. So x would be greater than or equal to 8. In the next example, and again, I'm solving these just like I would if they were two-step equations. Okay, I'm going to bring down my 4x. And it's a nice one step. And that would be our solution for the second inequality. Okay, now these are a little different. And in these inequalities, we are going to have to reverse the direction of the symbol, and I'll show you. So the first thing we're going to do here, we'll get rid of the constant. And then we would be left with a nice easy one step. So we'd multiply by 5. Now there's actually nothing wrong with that answer. But if we were asked to graph it, our graph would be wrong. It just makes it a little trickier to graph. We want to have the x on the left-hand side. And you can do that. Just remember, when you swap sides, you need to reverse the direction of the symbol in the inequality. And then that would be easy to graph. Let's do one more. So you'll notice the x is on the right-hand side. So at the end, we're going to have to swap sides. And again, that would be a perfectly acceptable solution. X is less than 8 is less than x. But if we were going to graph that, we could run into some problems here. We really need to have that x on the left side of the inequality. So you can go ahead and bring that on over. Just remember to reverse the direction of the symbol in the inequality. All right, let's just do a couple more of these, and we're going to graph the results. So here's a two-step. And now I've got a nice easy one step here. So b is greater than 13. So to graph that, that's how we would graph the inequality. And two possible solutions would be 14 and 18. Let's do one more. So this is just like solving an equation. I'm going to add 8 to both sides. And I have 7b is less than or equal to 49. I'm going to divide by 7. So b would be less than or equal to 7. So since 7 is part of our solution, I'm going to fill that in and would point in this direction. So a couple of possible solutions for that inequality would be 7 and -1. So that's how you solve one- and two-step inequalities.